If you're ever gone, there are video recordings of class unless I have managed to forget again. So well, I will try really, really hard to get the videos started, otherwise the makeup is always annoying. Anyway, my name is Aubrey. I teach some tutoring, I teach geometry, and I do the ACT prep. And a little bit of backstory to my ACT experience. Look,
No, continue. Just want to make sure to keep an eye on that
Yep.
one.
I just had one come in.
And you have to record it. Okay.
So, I went through school being very, very oblivious. I didn't know what a GPA was until I was a junior. And I moved to a small school and everybody was asking me, what's your GPA? And I'm like, I don't know. So that's when I found out. But I took the ACT in 8th grade as one of those things because my teacher told me to do it. And I just remember being really annoyed that they were so strict and I couldn't read, because that's what I'd done for standardized tests for my entire life, was I finish the test and then I get to read my book. And the ACT is very strict. There is no free reading, there is no phone. There's not even scratch paper unless it's the math test. They're very, very strict about what kind of influences you can have. Bathroom breaks are going to be really strict. Everything is really strict, so just be prepared for that. It's kind of weird, and if you've never done it before, it's like, why not? That sounds stupid, but it's very regimented and very strict. The other one is that 8th grade year, I got a 25. Okay. Some sections I was really, really good at. Reading comes very naturally, hence the book thing. And some of them are like, I have never seen this before in my life. And so the best thing about this class is I love that it just shows you this is what's going on. This is what it's like. These are what the questions are like. And so it's not that getting dropped into what on earth is this? I don't understand. The other one is that my junior year, I got a 32, and it's scored out of 36, and we'll talk about that a little bit more, how the scores work. And basically, it meant that my reading grade was still very high, my math grade was good, my English grade was not good, and my science was okay. And so it's like, well, I can do better than that. And I went back and I took it again the fall of my senior year. And I'd had a very, very good English teacher, and so the English score went up. I forgot my calculator. My math score went down because it's a matter of speed. It's just that sort of thing. Again, you can do them without the calculator, but it is slower. And with the math test in particular, you will find it's just trying to get it done. It's trying to answer everything. And so my math score went down, my English score went up, my score stayed right at 32. And at that point I'm like, well, I've already gotten admitted to college. There's absolutely no reason to take this test again other than bragging rights, and I just don't care that much. And so I moved on. But for you guys, again, you have this element of figuring out what's going on, and so that can really, really help you. There are only so many different types of questions they ask on these, and so I have taken about 10 tests now, prepping, going, oh, okay, I want a question like this, I want to have a demonstration like this. And after a while, you start noticing this is a kind of question you see a lot versus that question I have never seen on any of the other tests. That one's a random one. And so there's going to be a mix of these are the ones we get familiar with, and then they can still throw oddballs at you, and maybe you've seen it in prep, maybe you know it from school, maybe you're just like, I don't know. Important with ACT, none of you, a few guys have taken the prep class before, but the rest of you are fairly new. So just so you know, for ACT, guessing is not penalized. If you do the SAT, that one, the guessing is penalized. But for ACT, if you don't know, take your best guess. And if you have time to go back to it, that's great. If you don't, at least you've given it a guess. Don't leave it blank just because it's a multiple choice test, 1 out of 5, 20% chance you get it on luck. And really, the other thing that you'll start to do is being able to eliminate, I don't know what the answer is, but that one looks stupid. That's not it. And so that's what we're doing going forward. For today, we're working with geometry. Some of you have taken it, some of you haven't. But with our curriculum, it's kind of interesting. The pre-algebra 8th grade math level tends to have some geometry in it. And then we take algebra, and then we go back to geometry, and then we do algebra 2, and then they get into the pre-calc stuff. And so the best time to take the ACT, I think, is one semester into algebra 2. Because then you've taken geometry, you've refreshed the algebra stuff, and really it doesn't go beyond that. It's not going to have pre-calculus on it. It's not going to have calculus on it. And so for those kids that have had advanced math and they get speeding through it, really it goes back to basics, and especially the geometry, they get kind of rusty because it's been 2 or 3 years since they took geometry and now they're getting tested on it again. And so for you guys, I would very much encourage, you're doing the practice, that's great. You're gonna keep going to class, that's great. But the time that you really want to get your best score on the ACT is like halfway through that junior year when you're ideally doing algebra 2. So that's a lot of talking, but I thought it would help kind of give the background of what we're doing. So for today, we're doing geometry problems. I'm going to throw a problem on the board that's from a test and then talk about what tools you're using. So the first one is they tell us that we have a parallelogram. And other than a parallelogram, the only thing they tell us is that this is 25 degrees and they're looking for x degrees. The other thing you might want to have out is there's that spiral bound thin notebook with math in it. I'll refer back to this is on this page, and it kind of helps you have an anchor for the different things. We're going to be on page 3 with this problem. We're talking about parallelograms. So, not expecting you to shout it out, but just answer to yourself before I start explaining. Do you know how to answer this problem? So, parallelogram has this parallel in the name. And so what that's telling us is that the sides are parallel. These pink sides are parallel. These sides are also parallel. And so the concept behind this is parallel lines cut by a transversal. Trans means to cross. Transversal, it's crossing the two other lines. There's a whole bunch of rules about corresponding angles, alternate interior angles, alternate exterior angles, and you'll work with those in geometry. But the down and dirty, useful part of this is that these two angles are the same. They're called vertical angles. You can think about it as like a pair of scissors. You open the pair of scissors, the blades open, you close the pair of scissors, the blades close. And these are also the same. And so I call it the bow tie. But all 4 of these angles are the same. The other part that we have to work with is 360 is going all the way around in a circle. You talk about doing a 360. What is halfway around the circle? What's half of 360?
180.
180. So, very, very common is if you have a straight line and then this intersecting part, they're gonna add up to 180. They're gonna be supplementary. And so here, if we have these pink angles, this angle right here is what's called the supplement, or the missing part that makes 180. And so this is gonna be measured 180 minus the pink one. So if this is 50 degrees, this would be 180 minus 50, this would be 130. If this is 25 degrees, similar to what we have here, this is 180 minus 25, that would be 155. Now our pink angles made these bow ties, but our green ones are also going to be the same. And so when we have these parallel lines cut by a transversal, we have only two possible measures. Either it's the same or it's the supplement. It's the missing part that makes 180. What this means for this is this green line acts like a transversal for these lines here. And so, notice it goes green, pink, green, pink, pink, green, pink, green, this every other factor. In a parallelogram, if this is 25, our pink angle, then this is going to be 180 minus that 25, or our green angle. It will be the supplement. And so 180 minus 25, this is 155. Parallelograms, because they've got these pairs of parallel angles, the same way, if this is 25, the green ones are parallel, this is going to be 155. And if this is 155 and this is 155, this is 25, this will also be 25. And so within parallelograms, we have these opposite angles will be the same. We will have the opposite sides being congruent or the same measure. These sides will also be congruent or the same measure. And so within a parallelogram, there are lots of pieces that we can work with. It's just a matter of which one helps us get to the answer. Because the sides were opposite, that's great, but they were asked about an angle, so we need something with those angles, and that's going to go back to the idea of parallel. So, other things with a parallelogram, the more you can anchor it in your brain and connect it to other things, the better it is to work with. And so for a parallelogram, a real world example, how many of you have ever taken a cardboard box, taken the tape off the bottom and squished it down for recycling? When it's in box shape, it's that rectangle. It's got those square corners. But as you're squishing it down, that's when it turns into a parallelogram. It still has those sides the same. It's just no longer at right angles. It's turned into the flat until it eventually closes in on itself. But everything in between right angles to flat, it is in that parallelogram shape. So that's one of the things that can help you work with it. All right. So, next one, it tells us that an 8-inch by 6-inch rectangle is cut along a diagonal to form two triangles. What is the area in square inches of each triangle? And on this one, they don't give you a picture. The first thing I would be doing on this problem is drawing a picture. They do a decent job at giving you this space on the side when you're taking the actual test. And so you'll have your questions here, and they build in the scratch paper. if you're doing the practice tests in that blue book of 10 tests, that one is less nice because they don't give you the spare space in the interest of printing. They shove the problems closer together on the page and you just work on other scratch paper, but on the actual test, they give you that space to work with. So, 8 inches by 6 inch does not have to be beautiful. I guarantee this is not to scale, but all you have to do is write in, okay, I've got 8 inches by 6 inches. So, cut along the diagonal to form 2 triangles. Without my telling you, do you understand what that means? Yeah. Diagonals in any shape are going from corner to corner. They're called vertices in the geometry speak, but it's any straight segment that cuts from one corner to another corner through the inside. That's a diagonal. So we have our 2 triangles, and the question is, what is the area in square inches of each triangle? So, do you remember how to find area? Yeah.
1/2 times base times height.
Yes. And specifically, this is a great problem on the y of area. So we're going to go through the area of a few different shapes, but I want to build off of them. The most basic area, the rectangle. We've got rectangle. Sometimes it's called base times height. Sometimes it's length times width. Either way, it's the same thing going on. It's this dimension multiplied by this dimension. Very, very basic building block of area. So now with the triangle, we have 1/2 base times height. This is the most obvious of why. If this is our base and this is our height, base times height would be giving us the whole rectangle. The 1/2 is just acknowledging it's 1/2 of that rectangle. The next one is, well, what if it looks like this? Again, same area, 1/2 base times height. We have our base, we have our height, and we have 1/2 of that total rectangle again. It's just rearranged differently. The tricky one is that it still works even if our triangle looks like this. And the reason for that is, imagine slicing this like a stack of papers, or these ridiculously tall books. Even if I shove it sideways, the area is still the same. It's still the same height, still the same base. We can just stack it up and have a triangle. There's a more technical way to do that, but for now, you just need to have a working knowledge. You have a triangle, 1/2 base times height. It doesn't matter if the height is off to the side or not. So those two are set pretty well. How about our parallelogram? What is the area here?
Base times height.
Just base times height. It's the exact same as a rectangle. You can do it mentally with that kind of slice and shove, similar to the stack of the book. You can also see it as, well, if I cut this part off and moved it over here, it'd be the same length and I've gone back to a rectangle. Anything you can do to help you remember rather than trying to memorize a list of formulas, they're really not hard if you understand conceptually. It always goes back to comparing it to a rectangle. The last one that might come up, trapezoid. Trapezoid is going to be the odd shape. It has one pair of parallel sides, but the other two are not. And so these are parallel, but this is not. And it's the weird one. There are two ways to deal with trapezoids. Both of them are okay. So if I have, this is 7, and down here is 11. The formal formula for this is 1/2 base 1 plus base 2 times height. And remembering why, really kind of difficult until I show you the 1/2 base 1 plus base 2 is the average of those bases. It's how long this middle piece is. And so the same way you can cut off this triangle and put it up here, you can cut off this triangle and put it up here. This 1/2 base 1 times base 2 is turning this into a rectangle. And that's where it comes from. What if you still absolutely don't like trapezoids? What if you can't remember this formula? What you can do instead, just redrawing it. This is 7, this is 11. You can turn it into a rectangle and triangle. And we do need the height. I apologize. So base 1 and 2 are going to be the top and the bottom. Height will be how tall it is. I'm going to call this a 4. And so you can do this by finding the two pieces. What would be the area of the rectangle? On the inside there.
You multiply it to the 7.
So it's, the rectangle is going to be as long as the short side, or 7. And so this is 7 times 4. And then this is going to be put together into a triangle. Because we don't really know how long this piece is or this piece is, but we know that it is the leftover after you take away 7 in the middle. And so 11 minus 7 is going to be base of 4 left over. The height is still 4. And so 1/2, 4 times 4, this is a total of 8. And so you take the 8, add it to the 28, and get 36 total.
Didn't exactly understand how the base was equal to 4.
Sorry, what was that? You're asking where I got this 4?
Yeah,
Okay. So, on our original trapezoid, sorry, I'm going to drop down so you can see me easier. This top part is 7, right? And this part is 11. So if we take and cut out our rectangle from the middle, 11 minus 7, take away 7, is 4 left over. And so we don't know how long this piece is individually, but we know that together they have to make 4.
Oh, okay.
From the 11 minus 7. Great question. So those are our formulas for area. I don't think they do anything past a trapezoid. So that was a lot of scribbling, but good. We talked about parallel, we talked about area. Now I get to go back to all right, so now we've got this kind of blocky L shape, and they tell us this is 20, 8, 14, and 20 again. And they ask us for the perimeter. So, first question, what is perimeter? Yeah. The outside of the shape, the total distance around. Sometimes in common speech, they'll talk about walking the perimeter. You'll hear about it for soldiers or guards. They're walking the perimeter, they're walking the distance around the outside of whatever they're trying to guard. And so, for perimeter, we're trying to find the total distance around. If we were using wood or sticks, how much would we need? So, they're kind of very similar to that 7-4 problem, a little bit easier. These are all about what is missing on the opposite side. Here there's 7. That means that this distance here is also 7, and the leftover is what we need to in order to get to 11 or make up the difference. This one, a little bit easier. If this is 20, up here is 8, how much is missing to make up that distance of 20? 12. And the same way here, this is also 20, this is 14. What is missing to make up the difference? 6. And so we can find our perimeter this way and just add up the distances. So, what do you notice about my drawing? Not drawn to scale. My 14 looks about the same distance as my 6, and that will happen. Drawings are not always going to match up to what the answers are. That's okay. So don't freak out if you're getting, well, this says 6 and this says 14 and they look the same in my drawing. It happens. So not drawn to scale. You cannot assume anything from the picture. You can only work with the information they gave you. So, does anybody have a faster or easier way to solve this problem? Yeah.
You could just, because like up and down on the right side is 6 and 14, this is 20.
Yeah.
And then it's going to be 20 on the same side because of the 20 on the bottom.
Yeah. So you can imagine moving this stick over here and it goes up. Move this stick up to the top. It's over here. Essentially, we've got a giant square. It's going to be 20, 20, this will be 20, and this will be 20. 20 times 4 is 80. If you add them up, sure, 8 plus 6 plus 12 plus 14 plus 20 plus 20, you'll get the same answer. It's just a matter of how you see it and a little bit of speed. If you are going for perfect, if you're trying to get the 36, that means you got every question and every question correct. It's not that you have to be able to answer the questions. It's that you have to be able to answer the questions in the time they give you. And so every little bit of speed helps. If you're just trying to get a good enough score to be admitted into college, or you're just trying to do well enough to, I don't know, get a scholarship, there's lots of things that you can do. If you're trying for the 36, it's like practicing racing. You're just trying to shave off a little bit of time. And so it depends on what you're looking to get out of it. This way is perfectly fine. Seeing that you can flip it out and get the answer a little bit faster, that's going to make the difference if you're trying to go for perfect. All right. So we have a triangle given to us, and we have x, we have 2x and 3x, and we have a, b, and c, and we have a, c. So again, background information. In geometry, the points are labeled as these capital letters. So A is referring to this point at that corner. The B is this point, C is this point. Notice A is across from little a. Little a is going to be the length of this side. Little b is the length of this side. Little c is the length of this side. And then the x, 2x, 3x are talking about the degree measures of those corners. So that's just a little bit of the convention. They are saying, I'll read the directions, in triangle ABC shown below, the measure of angle A equals x, measure of angle B equals 2x, measure of angle C equals 3x. AB is C inches, so AB, they're talking about the distance from A to B. Again, that's just geometry background stuff. But the final thing that they ask is, which of the following inequalities correctly relates the side lengths of ABC? And so rather than multiple choice, we're going to do this from scratch. And that is ideally the best thing. There are some problems that you'll use the process of elimination and you'll want to look at those things. But in general, try to answer the question before you look at the options. Get your answer and then go and see if they have your answer. Because if you try and look at the stuff too much, it starts getting chaotic. So, if I have this triangle, and then I have this triangle, it's a stupid question, but bear with me. Which one's longer? The black triangle base or the green triangle base? Green. So, following up, we're always relating these sides to the angle across from it. So which is bigger? The black triangle angle or the green triangle angle? Green is open wider, it is bigger. Within the same triangle, that inequality is going to be the same. Bigger angle, longer side. Smaller angle, shorter side. We are going to be assuming that x is a positive number because it's a degree measurement. We aren't talking about negative numbers here. Geometry really stays in the realm of positives for the most part. So which is the biggest side? A, B, or C? Remember, don't trust the drawing.
C.
C. Because x, 2x, and 3x, 3 of something is bigger than 1 of something. 3 is the biggest. And so across from it is also the biggest. The same way, x is the smallest compared to 2x, a is across from it, a is the smallest. And so as an inequality, a has to be smaller than b, which has to be smaller than c. A is the smallest, C is the biggest, B is somewhere in the middle. So, I talked about common questions and uncommon questions. Everything that I've done up until now, those are common questions. There's gonna be perimeter, there's gonna be area, there's gonna be parallel lines. This is actually the first time I've seen something about the inequality property with triangles. And so, it's interesting, it's good to talk about, but if it was a choice of study perimeter or study triangle inequality, assuming you need help studying perimeter and you don't already feel confident about it, study the perimeter, study those areas. Because this one, I was kind of surprised to see it. Out of the 10 to 12 tests I've looked at preparing for this, this was the only one that had the triangle inequality. I think it's kind of cool, but it doesn't show up. So, other thing that's possible with these questions is getting bogged down on things that don't matter. You can see this problem, see the variables, and even I am tempted to start solving for x, because that's what's ingrained in our brain. Find x, find x, find x. And so you look at this problem, and even without thinking about it, my brain started solving for x, even though that has nothing to do with what they asked for. But since it's up here and it's a good time to have it, since I don't have to redraw, how would we find x? Yeah.
You'd add up the amount of x's there are, and then you divide it by, well, you take 180 divided by that.
Yes. So, property that's very, very useful is that the angles of a triangle are going to add up to 180. The proof of it has to do with the parallel lines, but for now, just be able to use it. No matter what triangle it is, it can be a very, very obtuse triangle, it can be a perfect equilateral triangle, but any triangle, so the angles of a triangle equal 180 degrees. In this case, we'd have x plus 2x plus 3x is equal to 180 degrees. Remember, this is, any x is just one x, so 1x plus 2x plus 3x, 1 of something plus 2 of something plus 3 of something, all total we have 6 x's, or 6 somethings. This is equal to 180, divide by 6, divide by 6, x equals 30. So again, this drawing is not to scale, not at all. If we were to have this situation, this would be 30 degrees, this would be 60 degrees, and this would be 90 degrees. Definitely not a right angle there. So, the angles of a triangle equal 180, and that is how you would solve it if they had asked you to. Bonus problem, that's not the original one. They were just interested in the ratio of the sides. How are we doing on time? Decently. Alright. So, next problem, again, they're asking about perimeter. Like I said, perimeter is one of those things that's definitely going to show up in some form. This one, they don't give us a picture. In words, it just says the perimeter of a particular rectangle is 36 centimeters. The longer sides of the rectangle are each 2 centimeters longer than each of the shorter sides of the rectangle, what is the length in centimeters of one of the longer sides of this rectangle? So, first thing, we have a rectangle. And we know that the perimeter equals 36. Frequently, capital P is kind of the standard default for perimeter. I don't think they'll ever give that to you without telling you that it means perimeter, but just for things. So, we are looking at the short side and the long side. And what they tell us is that the longer sides of the rectangle are each 2 centimeters longer than each of the shorter sides of the rectangle. There are 2 ways to do this, both of them are okay. You can choose to start with this side or start with this side. But we're going to be assigning it a variable. We don't know what that side is, we're just working with it. Because they ask us to, what is the length in centimeters of one of the longer sides of the rectangle, I'm going to make the long side our variable, the thing that we're hunting for. Because otherwise you're going to have to go back and make sure that you get the right thing. So, X is traditional. You could call it L for long side. You could call it A just because it's at the beginning of the alphabet. It doesn't matter. But if the long side is X, what will our short side be?
X minus 2.
X minus 2. Because the long side is 2 longer, that means the short side is 2 shorter than our X. So this is X minus 2. What do we need to find for perimeter? We're doing the outsides. It's all the distances around. So when we have a rectangle, if this one is X, what's down here?
X.
Also X. If this is X minus 2, this is also X minus 2. And so we are going to add all of these up. We have an X and an X and an X and an X. I have 4X. And if you need to write it out and combine it, that's okay. But we're subtracting 2 and subtracting 2. We're taking away 4. And this is equal to our perimeter, which was 36. Now we're very much on solving for algebra. Geometry and algebra do get mixed together fairly regularly. We would be adding 4 to both sides to get the 4x by itself. 4x equals 40. If you have to do a calculator, great. But if you don't, it's okay to say, oh, x is 10. We're dividing both sides by 4. So again, because we chose x to be the long side, that's the answer we're looking for. But if we had done this differently, if we had said that this is x and this is x plus 2, it would solve the exact same. You'd still add things up, you'd still work with it, and we'd end up with 4x plus 4 equals 36. Subtract 4 from both sides, 4x equals 32, x equals 8. But you would have to make sure that you go back with your x and find the length of the long side. Because they ask for that long side, but guess what the very first multiple choice they offer is? 8. And so they will offer you the right answer on a silver platter. They think it's fun. They know exactly the mistakes people will make, and they offer that as an option. The multiple choice wrong answers are not random. They are specifically chosen to, if you make this error, this is what answer you would get. So make sure that you are answering the problem they asked for. If they ask for the long side, you need to give them the long side. Don't say, oh, I found a side, and find it in the answer list. So, not hard, just annoying. Right. The next one is another thing that is always on the ACT test, not necessarily going to be this problem, maybe not necessarily even geometry, but there's always this one bank of questions that they give you a piece of information and then they ask a set of questions about it. Sometimes it's a table of data, but they'll give you this bank of information and then 3 or 4 questions about it. And so in this particular case, we have a parallelogram again. Yeah, that marker is getting reddish. Let's try a different one. Much better. So we're given this parallelogram and we're told that the top is 2 over 3n minus 5. And they also have our diagonals drawn in again. And above is 71, and below is 42. And I've gone and mirror image this, so it's not helping. We have a center intersection is E. So, other thing to get familiar with, they give you this drawing, and then they proceed to give you the exact information in written form. It's good to get used to skimming it to make sure you're not missing something, but it's okay to say, okay, I've got that, I've got that, I've got that, good. So in parallelogram ABCD shown below, the diagonals intersect at E, and the measure of BDC is 42. The measure of BDA is 71. It traces the angle of B, D, and A is 71. And AB, or the distance between these two, is the 2/3 n minus 5. And it says, note, the figure is not drawn to scale, and the M angle, it's written as M angle PQR, denotes the measure of angle PQR. Fairly familiar if you've taken geometry, less so if you haven't done it before. So, going over this, PQR traces the angle. They're just using it as an example. So, back to the angle BAD. And yes, sometimes they spell things and you can't help but notice them, but move on. It's angle bad. But this says start at B, go to A, go to D. And it traces it out. Angle BAD crosses over both those two drawn angles. It's the large total. So, in geometry, more than anything else, it's about focusing on what you need and ignoring all of the other things. We did parallelograms at the beginning of this class, and we found out that this angle and this angle have to add up to 180 degrees. So, if this is 42 and this is 71, how do we find the total angle CDA? What would that angle measure be? Calculators are okay.
115.
67.
I think you're getting the next answer. So, 113 is this angle down here at the bottom. You're just taking 42 and 71 and adding them together. And so this total angle is 113. Now, back to the idea of supplementary, they have to add up to 180. Our pink angle up here is going to be that 180 minus 113, which was
67.
67. And so, all of that diagonal stuff right now didn't make a difference at all. All those lines did was distract us. But, like I said, this is going to be asking a bank of questions. And so we're going to go back and deal with the extra information like, what on earth? We didn't use that at all. But it's coming.
I have a question.
Yes.
So basically, are we supposed to find angle EAD by doing 180 minus 71, or do we just like find the whole angle A?
Sorry, what was the first angle you said?
So are we supposed to find what angle EAD is, or find what angle BAD is? Like,
They asked us for BAD, so we needed to find BAD. EAD we can find later possibly, but that's not the one they asked for. We were just looking for that total. Very good question. So because they asked us for angle BAD, that is the one we were looking for. So the next one says, given, which is geometry speak for, we're telling you to assume this is true, but given that DC is equal to 1/3 n plus 7, what is the value of n? The other thing in geometry is you're always looking to start with a relationship. What relationship can you use, and then switch it into the algebra and solve. So DC, or CD, doesn't matter the direction, is this length right here. They gave us this piece of information. So that's probably what we're aiming for. What's the relationship between CD and BA?
The same.
They're the same, they're congruent. Again, back to the idea of a box, and that box has been squished. That top and bottom are still the same. And so we can set this up as a solving equation. 1/3 n plus 7 equals 2/3 n minus 5. And now we're out of geometry, back into algebra. Very basic solving. I don't like negatives, so I look at 1/3, I look at 2/3. 2/3 is bigger. I'm going to subtract my 1/3 over. 2/3, take away one of them, I have one left. If I moved n over here, I'm going to move my 5. 7 plus 5, 12 equals 1/3. Do not be afraid of fractions, but do be aware of them. How do we cancel out 1/3?
Times 3.
You divide by 1/3, which turns into multiplying by 3. Both are good as long as you understand what's going on. But we're going to end up multiplying by 3, and we get 36 is equal to our n. Was that a question or just a thought? Just a thought. All right. So now I'm going to erase out so we have a little bit more space. They go back into coordinate geometry. And since I drew it backwards, that's not going to work. We're going to skip over that one. So it says, which of the following triangles is congruent to ABE? As near as I know, you're only allowed pencils. I would think that colored pens would help, but I don't believe they're allowed. But if we're focusing on A, B, and E, there is a geometry property that goes with this, but I'm not 100% sure that you guys have learned it and or remember it. So this one is a practice in gut instinct. Gut instinct is a valid thing to use on the ACT, especially if you're not going for that perfect 36. Using the best you can, which triangle do you think would be congruent?
CED.
CED. It's this one on the bottom. It has to do with a lot of different things. We have those alternate interior angles. These angles will be the same. We have these angles being the same. And we have the idea that these diagonals are bisecting each other is another thing that's useful with parallelograms. But if you don't know that, give it your best guess. There are lots of things that are the same. We knew that these sides were the same, and so that's another thing you can build off of. But if you don't know, give it your best guess. Which one looks like it would work? Ideally, it's best to know the answer, but if you don't, give it a guess. All right, we're gonna go ahead and take a 5-minute break, and we'll switch teachers. I'm not sure what topic Manoj is going over with you, but that is the start. So, just so that I have the perspective going forward of the people in person, how many have taken geometry already?
I'm in it now.
In it now? That works too. Okay, so about half of you. And of those of you online, go ahead and just shout it out. How many of you have already taken geometry?
I'm in it now.
In it now? Okay. So,
I'm in it now.
in the
I'm in it.
standard pacing, you are probably starting these parallelograms now. If not, it will be coming very, very soon. So this is right on your what you're learning now or in the next few weeks. So we will probably come back to geometry again before the end, but in general, is that the right speed? That's the other thing. Okay, and is it about a good difficulty? Okay, then we are doing good. I'll go ahead and stop the video. He'll be back in 5 minutes.